All right, hey everybody. This is going to be a Raspberry update. So the team is coming together, which is nice, and we've had some good discussions, and we've got a lot of traction, and a lot of people are interested. However, what I will ask is that if just before we get started, please read the contributing document before you try and submit any pull requests or jump in. We're moving fast, so we don't really have time to catch people up. If you do want to participate, we do welcome conversation, but the onus is on you to catch yourself up. Okay, with that out of the way, we're working on step one, which is synthesize complex user queries. We'll start by synthesizing 500 distinct user queries across a variety of challenging domains and tasks. These user queries will require a variety of skills and abilities, such as math, coding, logic, reasoning, and planning. They will span numerous domains from medicine and science to software development and other economically valuable sectors. After initial synthesis, we will use rubrics and similar grading techniques to measure and improve the samples. So, we had a really good discussion. So Christoph, actually from Leon, reached out. He commented and has been contributing. And so we've had, this is by far the best conversation. Let me give a little rocket so it's easier to see. And so we're talking about all the various approaches. Like, what kinds of reward predictors are we going to train? What kind of models are we going to fine tune? What we suspect is that this was done with something a little bit more sophisticated than just a simple GAN. So a GAN is a generative adversarial network where you have a generator and a discriminator. What we suspect is that there's actually probably several steps that they used to either synthesize the data and or reinforcement learning, fine-tune the model, or however you want to word it. However, my expertise is in fine-tuning. We will be working on where we've actually got some friends and friends of friends who are working on getting us resources to do a full reinforcement learning run. But fine-tuning is something that we have access to. So the TLDR of this very long conversation is that we were talking about basically one, what kinds of models do we need in order to clean the data? But then also we need a way to create provable reasoning. And so provable reasoning basically means that, yes, I gave an example before about how Claude is able to read through reasoning and then solve that, or basically say, yes, I agree with this reasoning. This reasoning is sound. However, for something to be provable, it means that you need some external validation other than the model checking itself. Now, I did show that there's plenty of research papers out there showing that models are capable of grading themselves and each other. However, for the best logic, you need something that will actually run code and say, yes, this code worked, or run math and say, yes, your math is correct, or in other environments. And so through conversation, what we talked about was using gaming or simulation. And so a few possibilities popped up, which is chess, Mastermind, and Battleship. So those are adversarial games that are provable, meaning that you can run it in a simulation environment and know that the solution that you proposed, whether or not it actually worked. So those are some of the things that we're aiming for. We're not quite there yet, but that's the direction that we're going. Also, we've realized the general consensus out there on the internet is that Strawberry was trained with three primary techniques. So number one is chain of thought reasoning. That is the most obvious one. Number two is possibly reflection. And number three is, did I say that in the right order? Number three is Monte Carlo tree search. There we go. So basically by incorporating those three techniques, that takes it one level above RLHF and all the stuff that generated ChatGPT. So that's the direction that we're going. And I haven't had anyone on the internet say, no, you're wrong. The conversation has shifted from, oh, Dave, whatever, you're just making stuff up, to, well, now you need evals. So if the goalposts have moved to now you need evals, that's basically tacit confirmation from people at OpenAI that this is how they did it. So look at what's not being said. They didn't say, no, you're wrong. All that they said is, we did more than fine tuning. I was like, okay, so you did more than fine tuning. You did reinforcement learning. Then they said, well, now you need evals. Okay, cool. That's where we're at. So I've updated my own personal repo. So I've got Raspberry experiments where this is where I'm just kind of containing my own sandbox. And I've generated the first batch of questions. So I'm particularly happy with this one. So, as a neuroscientist specializing in brain-computer interfaces, you're tasked with evaluating the potential risks and developing mitigation strategies for a groundbreaking neuroprosthetic device that aims to transcend current limitations of neural interfaces. This device proposes to use a novel combination of invasive microelectrode arrays and non-invasive EEG sensors to achieve unprecedented bandwidth and accuracy in decoding complex motor intentions for patients with severe paralysis. That is very specific, and this was 100% algorithmically generated. I will show you how I did it in just a minute. Given the high-risk nature of this integration, what are the primary safety and ethical concerns you would need to address? How would you design a comprehensive risk assessment protocol that accounts for both short-term surgical risks and long-term effects on neural plasticity and cognitive function? Additionally, propose innovative approaches to mitigate these risks while still pushing the boundaries of what's possible in brain-computer integration for neuroprosthetics. So this is an example of a highly complex question that would require many, many steps and expert reasoning to get through. However, this is not a provable question. It does require reasoning, but it's not provable. So in our ultimate data set, or whatever system we build for training a model, we want to have both provable and unprovable problems. And also, a lot of people have suggested removing any erroneous logic or dead ends, and that's a really bad idea. And the reason is because within the training data set, you want the model to actually see what making mistakes looks like, how to catch itself, and then how to backtrack. A few of the tweets, particularly from Noam Brown and other people at OpenAI, hint that, and also this is the interpretation of other people, that the way that Strawberry works is that it is able to catch itself when it makes a mistake and is able to backtrack. So we don't want to clean up the data so much that it only has perfect logic the first time. You actually want the model to be able to recognize mistakes. This is something that we studied a lot in doing cognitive architecture. And recognizing itself catching mistakes is actually one of the ways you reduce hallucination. You need it to go through and say, wait, that's not right. I need to backtrack and try a different method. And so, with all that being said, I want to show you how I did all of this. So first, I went over to Perplexity, and because I don't really feel like reading the documentation, I just said, can you synthesize... wait, hang on. That's not the right question. Where did it go? Here we go. Sorry. Can you write the simplest Python function that receives an API key and a prompt and returns a text response from Claude, Anthropic's API? And so then it just wrote a very simple, yes, here, I wrote it for you. So I told Perplexity, people are confused when I say that Perplexity can code for you. I'm just like, just go search the documentation and write a function that does this for me. And so it did it. So I was like, cool. So I did some cognitive offload where I didn't even need to think about that. So then I came over to Anthropic's console, so the workbench, and I did some tests here to make sure that it was all working. Now, let me show you the full process. So I opened up Claude, so armed with this function call and knowing that everything works. So you get the code and you say, this is how it works. This is actually really helpful because then you just copy paste the code that actually worked for the function call. You just tell Anthropic or tell Claude, this is what it worked. Anyways, so rather than documenting the process as I went, I just want to walk you through everything that I did for educational purposes. At this point, if you want to learn, that's great. If not, then you're not going to see anything new. I showed you what the overall process was. Okay, so I said, I have a programming project where I need to come up with many challenging questions across many domains. This is to create a data set of tough questions such as for an AI benchmark. This should include stuff like math, STEM, coding, medicine, logic puzzles, brain teasers, etc. Each question should be answerable with no external resources, require multiple reasoning steps, such as thinking through or writing out problems. And then here are some examples. And then I gave it the examples that I've accumulated from various places. I said, okay, let's pause and first see if you have any questions. Do not do any work yet. The reason that I say this is because Claude is often a little hot on the biscuit to get going. So I was like, no, let's just talk through this. And it said, I understand the project. It should be answerable without external resources, require multiple steps, and cover diverse fields. Cool. Before we proceed, I have a few clarifying questions. How many questions are you looking to generate? Do you want an even distribution? Is there any particular difficulty level? Are there any specific types of questions or domains you'd like to avoid? Also, let me add the cursor highlighter so you can see. There we go. Do you have any questions? Do you want the questions to come with answers or just the questions? I said, well, we'll need to come up with an automated way to generate an arbitrary number of questions. Number 2, I said we're going to be able to generate questions automatically, but the chief point is to generate them algorithmically. We're going for maximum difficulty, graduate, postdoc, and world expert level. No, blah, 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 blah. You get the idea. So then Claude does some reflection. And then I gave it some of the work that I did yesterday. I said, look, you are capable of multi-step synthesis and checking now that you're up to speed. And by the way, this is the conversation that I showed yesterday. So I said, can you verify that this process was correct? And this is the data that I showed you guys yesterday, where Claude was able to verify its own work, which again, the scientific literature demonstrates that LLMs have been capable of validating each other's work and grading each other's work. That is really important. So not only can we synthesize questions, we can synthesize answers, then we can validate the answers and clean them up. So those are all the steps. So now we're actually getting into the meat and potatoes of it, of actually generating the questions. So after a little bit more back and forth, I asked it to brainstorm, like, okay, what kind of approach are we using? And so what it said is, we need a main topic list, we need subdomain, then we need difficulty modifiers, problem type modifiers, and conceptual connectors. So let me show you what that looks like over here. Here we go. So the TLDR is what we did, is we generated 4 lists. So we generated a list of main topics. So we've got mathematics, chemistry, biology, computer science, engineering, economics, philosophy, blah, 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 literature, so on and so forth. So these are all really, really big, high-level topics that are all scientifically and economically valuable. And so that's kind of the distribution, rather than saying like solve, ArcAGI. As you guys probably remember, I'm not a big fan of the ArcAGI challenge because it has no academic value and it has no economic value. It's basically a Sudoku puzzle, and I am standing by that. I know that'll piss some people off, but the ArcAGI challenge is irrelevant here. Okay, so we've generated a few lists of main topics, and then we also did difficulties. So the difficulties are like graduate level, postdoc, expert, world-class expert, cutting-edge research, blah, 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 blah. Now, if you watch my videos in the past, generating several lists that you can choose from randomly is a really good way of getting entropy into these models. And so we have 4 lists, each that are like at least 20 long. So you multiply that out. You have, so like 20 times 20 times 20 times 20, basically that's a lot of possibilities. And so then what we did was we went through a lot of back and forth. So here you can see it generating the lists, and away we go. And then what we needed to do was create a placeholder. And so the placeholder looks like, or a template rather, sorry. So prompt generate a subtopic. So the subtopic generator, the purpose of this is you take all of those random lists and then you feed it to Claude. You feed it back to Claude and you say, so I said, the prompt that I give Claude is, hi, I am working on a research project and I need to synthesize good test questions. However, part of this is that I need to generate a good subtopic given some context. So main topic, difficulty level, problem type, conceptual connector. And this is what you see what I did here. So this is an example of me testing this prompt in the workbench. Okay, so I said generate a specific challenging subtopic or secondary topic that is answerable without external resources, requires multiple reasoning steps, and is suitable for placeholder difficulty level of expertise. The subtopic should be narrow, specialized area within or related to main topic, potentially incorporating aspects of problem type. It should be complex enough to warrant conceptual connector in its exploration. Consider cutting-edge research, interdisciplinary connections, or theoretical extensions of current knowledge in main topic. The subtopic should be specific enough to form a basis of a highly challenging question that would require deep expertise and complex reasoning to answer. So basically, very clearly telling it what it wants. Oh, and by the way, Claude generated most of this. I did a little bit of cleanup. I said, provide the subtopic as a brief phrase or sentence, no more than 15 words long. Do not include any other replies or data, or any other replies, as this is a data synthesis step. So let's see. Yep, and so you see right here, this is where I told Claude, now we need a default prompt with placeholders to send to your API. The first one will generate the subtopic. And this is that you can see Claude actually generated most of the prompt. I just did a little bit of cleanup. So Claude is a great pair programmer here when used correctly. Okay, so we've got the subtopic generator, and then what we did was we tested so here's me testing the subtopic generator, just making sure that it actually works. Now we had a little bit of back and forth because my function call was wrong. So I said the API didn't like it. It gave a refusal. And then by coming back over here and just clicking Git code, I was like, okay, here's what the code actually, this code actually works. So then I came back and said, let's see, over here, this was me still troubleshooting. I said, it works in the web interface, but it doesn't work on the API. And I said, found the problem. The code is out of date. So then I gave it, here's an example of the real code, and it updated the script for me. So the script is over here. Let me close some of these superfluous tabs. So the script is over here that we ultimately created, which is generate question. So generate one question here. Let's go back because this is, there we go. So generate question. So import Anthropic, import random. Actually, I realized that I probably need to add random seed back to this. Yeah, because unless you instantiate it with random. So here, generate question, random seed. So what this does is it tells it to basically update its own internal entropy so that you get even more randomness. So I'll push that change to main in just a minute. Anyways, so read list from file. So it's reading those lists that we created. So we got main topics, difficulties, problem types, and conceptual connectors. Generate question parameters. So it's generating a parameter function. Format the subtopic prompt. So that's actually filling in the subtopic prompt that we created over there. So I guess I already closed it. Sorry. Actually, no, it's over here. Prompt. So yeah, so it's filling in the placeholders there. And then we query Claude. So this is basically just borrowing the code that I got from the workbench, and then generate a subtopic. And then I have it use the key, and it spits it all out into the console, which we can see happening here. So you can see here's where I was running some of the tests. So here's the generated prompt, yada, yada, yada. Subtopic, end of prompt, API response. The ethical implications, an authorial intent, yada, yada, yada. So here's the final output. So you see it's working. And then the next thing that we ran was generate many questions. So we can generate an arbitrary number of random questions. So here, generating question 1.1 out of 5, history, counterfactual analysis question. What would have been the potential ramifications for European power dynamics if the Principality of Liechtenstein had... let's see. Hang on. We're not seeing the whole. Oh, that's too long. Anyways, so it generated a good question. And that's actually over here. You can see the full question in Raspberry Experiments, questions, and then this one is probably history. Yep. So had Liechtenstein successfully negotiated a marriage alliance with the House of Bourbon-Parma in 1784? And how might this hypothetical union have influenced the diplomatic strategies of neighboring microstates like San Marino and Monaco during the lead up to the French Revolution? This is such a complicated question. Drawing parallels between this counterfactual scenario and the actual diplomatic maneuvers of these small states, analyze how such an alliance could have altered their survival strategies and relationships with larger powers in the tumultuous final decades of the 18th century. Ooh, that's a mouthful. Okay, so you see that this process works. It actually generates very, very powerful questions. And again, these are not provable questions, but if you were to give this question to Strawberry, you could see that it will do a lot of reasoning to say, okay, this is what we know, this is what we don't know. How can we generate this framework? Okay, so where were we? It said, excellent, it worked except for one error. So there was one little, we had to update a couple of functions, and so on and so forth. And then I manually wrote something to generate the question. So here is when I just went over to the, oh wait, no, this was testing the subtopic generator. This was actually generating a question. So I took one of the subtopics that we had generated, and I wrote my own prompt. And so I said, please just output the query. as a field-defining scholar in post-colonial literature, yada, yada, yada. So it generates a very comprehensive question that requires many-step reasoning. So then moving on, that actually gets baked into a whole other script, and that whole other script is over here. Oops. Come back. Sorry, I'm clicking too fast. Dave is too clicky. Okay. So then we generated, I basically just asked it, I said, generate this whole script in one go. And I said, let's see, where's the script? Oh yeah, so I gave it, here it is. Here's the whole script. I said, excellent, I understand you want to automate the process and create a second prompt to generate the final question, yada, yada, yada. So it generates an entire script. So prompt generate question. So that's what we did here. And I tested it and I said, all right, now we need to save our work. And I said, make sure to output the entire rectified script. So it literally, with all of this work, it was able to output the entire script in one go, and it worked the first time. I also see that I need to add random seed to this one as well. So let me go ahead and do that real quick. So this was generate, let's see, many questions. So we'll come up here and just add random seed. And that's pretty much all we needed to do. I don't know why, but a lot of code writers won't add that. They'll just do random functions without instantiating the random seed. Anyways, so you can see that was the end of this conversation. I literally just copied this script out as it was verbatim over here and ran it. And you can see it running, generating question 3 out of 5, political science, reframing global power dynamics through fractal patterns in geopolitical decision-making processes. Good grief. So there you have it. We have a question generator. This is not the provable question generator, but we can generate functionally an unlimited number of questions. This kind of data synthesis is what I've been working on for the last 3 years, which is why when people say, oh, OpenAI solved data synthesis, they solved, you have functionally unlimited data. When you also add bolted on things like API calls to test the math, to test the coding, to run in simulations, then you even have a fully provable set of data as well. So now that we've got a question generator, next we need is provable examples such as playing chess and those sorts of things. So math, coding, and games are kind of the 3 next categories that we need to get. But once you have a functionally unlimited data set, you have solved the data problem. This is how OpenAI solved the data problem. And by the way, we solved this problem 3 years ago, which is another reason that I'm not super impressed by the science. But the economic impact, that is where it's impressive. Okay, I think I'm done today. Just to, as we wind down, Raspberry experiments, you can look at what I just pushed. If you want to look at the questions, they're here. I also have everything saved out to log, so you can see everything that it generates. So trace logs are really, really useful for this. But really what it comes down to is generate question and fundamentally generate many questions. This is the crux of what I achieved today. So now we can generate a lot of questions, and then we'll use the process that I showed proved out yesterday or the day before, whenever it was that you're watching this, to then answer the questions with multi-step reasoning, and then validate the answers that it generated with multi-step reasoning, and then clean up the data. So that's where we're at right now. Yeah, thanks for watching. I look forward to seeing where everyone goes with this. Cheers.